In this video, we're going to explore graphs of systems of linear inequalities. And what that means is it is a set of two or more linear inequalities that are graphed on the same coordinate plane. The intersection of their solution regions represents the solution set for that system. So in this picture, this darker green shaded area would represent the solution region for both those graphs. So we're going to graph the system of linear inequalities and choose two possible solutions from the set. So here, and yes, these little lines should be over here, but they're not. So if I look at the first one, my linear inequality is 3x plus 2y is greater than -6. And I'm going to turn that into y equals mx plus b format so that I can graph using the slope-intercept form. So I'm going to move my x's over, and then I'll get my y alone, so I'll divide by 2. Okay, so my y-intercept is at -3, so I'll put a dot at -3, and my slope is down 3 over 2. Good, and that's enough to make a line. This line is going to be dashed because my inequality is greater, not greater than or equal to. So there we go. All right, linear inequality number 2, y is less than or equal to 3. So here there is no x value, it's just y. So my y number line, I'm going to find 3. And all my values are going to be y is less than or equal to 3. So that line is going to be solid, and it's right across all my values where y equals 3. Now I've got to figure out where my solution region is. So let's go back to my first linear inequality and figure out if I'm above or below the line for my solutions. So I'll plug in the point 0 and 0 because it's my favorite and it's the easiest. And I get that 0 is greater than -3, which it is. So then all my answers are going to be above this first line. So I'm just going to put those arrows because I don't know where my answers are yet. Now for my second linear inequality, if I was to plug in 0, I'd get 0 is less than 3, which is true. So all my answers are below this line. So is there a shared region between these two lines? Yes, it's right in here. And because I'm dealing with real numbers, I get to shade in that region. So I'm going to color in that region, and here are all possible solutions. So if it wants me to choose two possible solutions, let's choose, we can do this point right here, which is the point 1 and 1. So 1 and 1 is a possible solution. This guy over here, which is 1, 2, 3, 4, 5, 6, 6 and -1. So any points that you choose could be possible solutions. All right, here's our next question. We're going to start with the first linear inequality. 2x plus 3y is less than 9. I'm going to change it to slope-intercept form. So move over my 2x so that y can be by itself. Divide by 3. There. So my starting point is my y-intercept, which is at 3. And then I'm going to go down 2 over 3. Down 2 over 3. Now this line is going to be a solid line because its y is less than or equal to. So I'm going to make my line. Good. Where do my answers lie? Well, I'll test a point. So I'll test 0 and 0. And I get that 0 is less than or equal to 3, which is true. So I'm below the line. All right, line number 2. Y subtract 6x is greater or equal to 1. So I'll move over that 6x by adding 6x to both sides. My y-intercept is 1. My slope is 6 over 1, so I go up 6 over 1. 1, 2, 4, yep. And it's going to be another solid line. There we go. And my answers, if I check a point, 0 is greater than or equal to 1, which is not true, so I'm on this side of the line. And I'm dealing with the integers, so I need to dot on those intersections. So here's my shared region, and I'm just going to put a couple dots to show where my solution region is at. There, good enough. Choose 2 possible solutions. Well, we can choose this point right here, which is the point -2 and 0. So my x value is -2, my y value is 0. This guy over here is -1 and 3. So there's another solution. All right. You can validate a possible solution from the solution region by checking to see if it satisfies each linear inequality in the system. So for example, validate if 2 and 2 is a solution to the system x plus y is greater or equal to 1, and 2 is greater than x minus 2y. So let's look at the first one. X plus y is greater or equal to 1. I'm going to plug in 2 and 2 and make sure that it's true. So for the first one, yes, it satisfies. 4 is greater or equal to 1. My second linear inequality, 2 is greater than x minus 2y. If I plug in 2 and 2, I get that 2 is greater than -2, which is true. So yes, 2 and 2 is a solution to my system. And in summary, so some situations can be modeled by a system of 2 or more linear inequalities. All the inequalities in the system of linear inequalities are graphed on the same coordinate plane. The region where their solution is shared is the solution set for the system. So here is my example. Here are my 2 systems, and these lines once again should be over here, but we get a little bit of a formatting error. And here graphed are the 2 lines, and this is my solution region. As with the solution region for a single linear inequality, the solution region for a system of linear inequalities can be discrete or continuous and can be restricted to certain quadrants. So for example, the graph below shows a system described below. So notice that we are only in that first quadrant, and I'm dotted because I'm dealing with whole numbers. See my system, it shows W for whole numbers. So this data is discrete. It's not continuous. It doesn't involve every single number that we can imagine. It's just those whole numbers. Just like in that other example, we only had integers, our positive and our negative whole numbers. So use an open dot to show that an intersection point of a system's boundaries is excluded from the solution set. An intersection point is excluded when a dashed line intersects either a dashed line or a solid line. So let's go back. Notice in this question, this line here is dashed. So we would use an open, I'll even dash it here, and this one is solid. So we would use that open dot to show that the intersection is not included. So yeah, you can go back to the following practice. Practice number 5, Systems of Linear Inequalities, questions 2 and 3.